Now we get to look at hyperbolas. If you look at them, they look real similar to ellipses. The only difference, in fact, is the minus where we're expecting a plus. If there was a plus sign, we know it's an ellipse, but this subtraction indicates that it's a hyperbola. The other interesting difference about hyperbolas is that the variable that is in front controls the orientation of the hyperbola. If it's x in the lead, then my hyperbola is going to be horizontally oriented, and I'll see two curves facing away from each other. Kind of looks almost like an ellipse that's been turned inside out. Similarly, if the y comes first, then my curves are going to be vertically oriented and facing away from each other. And how do we know what shape it is? Well, let's practice. We're going to use the information much the same way we did with ellipses. The center is still at HK. So if I look for H and K in this one, there aren't any values specified. They're not there. The only thing they could be to get that to go away is 0. So I know that my center is at 0, 0. I can go plot it. The next information, we're going to use the exact same way we did with the ellipses. I'm going to look underneath the x squared and take the square root. This gives me a value of 3. So from my center, I'm going to go left and right 3 units to mark that. And then under the y value, I see 25. Take the square root of 25 is 5. So in the y direction, we're going to go 5 each way. Okay. Now if it were an ellipse, at this point we would connect them and close that together and have our picture drawn. But it's not an ellipse, it's an hyperbola, and I have curves that are facing away from each other. I know, since the x was in front, that this is horizontal. So somehow or another, I'm going to have curves that face out. The way we figure out exactly how wide or narrow they are is we're going to use these dots that we plotted to make a rectangle that's just lightly sketched on here. And the reason we make a rectangle is because hyperbola have asymptotes, and those asymptotes run diagonally through this rectangle. We already know that an asymptote is a place in the coordinate plane that a graph approaches but can never touch or cross. And so once I have those set up, now I know that I can come in here and draw. I know exactly what the shape of my curves are because they're going to run and chase and try to get there. But never will. It's going to follow each side. Okay. The asymptotes aren't part of the graph, they're just a boundary. So we made those a lot lighter. Okay. Sketch that out. Follow along. And there is our horizontal hyperbola. Those curves open along the horizontal axis. Still has vertices and co-vertices. The actual vertice of the curve, those are our vertices. And like an ellipse, it has co-vertices. These are those other points that we use to draw our rectangle, but aren't really a part of the graph. The actual hyperbola itself is just these two curves. So we'll follow the same process, but in example 2, we know that it's going to open vertically because the y is in front. So again, we can see that our center is at 0, 0. There's nothing in there with the squared variables. Mark it. Our y squared this time is sitting over 16, so when we take the square root of 16, we're going to travel 4 units in the y direction. Okay, and I'm just going to lightly mark on here, these are the vertices of our curves, so we don't forget later on. And our x sitting over 4, so horizontally we're going to go 2 units. And we're ready to draw a rectangle. Lightly so it doesn't get in the way. It's not part of the graph, it's just a tool we use to make the graph. And connect our diagonals, extend through. And now we can see what our curves are going to look like. Much more narrow this time because our rectangle was much more narrow. Still following the shape of those asymptotes. If you zoom out of a graph of a hyperbola, if you were to get it in your graphing calculator, they eventually start to look like an X because they just follow along those asymptotes. Okay, and now we're looking at one that's open vertically. My vertices this time have moved with my curves, and they're sitting right there where they change directions, and my co-vertices are now along the horizontal.